Hi everyone, our lesson today is permutation with and without replacement, and we are going to deal with the issue of lottery ticket issuance today. So the problem is stating that a lottery corporation want to issue tickets using the 26 English capital letters. So immediately we have here 26 objects, 26 letters, and N, the number of objects, is equal to 26. Now, if the ticket is composed of 2 letters only, then we are going to have sequences with 2 letters, which means that R is equal to 2. So R is defined as the number of letters in the generated sequence, and the ticket is composed of 2 letters, so R is equal to 2 in such case. Now the first question: how many tickets can be issued if the player can choose one letter from each of the 2 lines in order? So the lottery tickets has 2 lines, the first line where all alphabet are written, and the second line, and the player must choose a letter from the first line and letter from the second line in order. So let's see, he is choosing T, let's say, and we are writing it outside as the first withdrawal, and he is choosing the letter H, and we are writing it outside as the second letter. And now we have a lottery ticket composed of 2 letters in order. The first one is T and the second one is H. Now the question is, can a letter be repeated or not? Let's see. He may choose letter Q, and then again he may choose the letter Q again, and we have now 2 letters, and now we have the ticket QQ, so yes, it is possible to repeat the letter. So that will answer the question that our withdrawal has replacement possibility. So now we have the 2 conditions. The first one is ordered letters, because the problem is stating that one letter from each of the 2 lines in order. So this in order means it's mentioned clearly. And the second thing, we have just understood that replacement or repetition of the letter is allowed. So in such case, we may get tickets or sequences such as AB, where no letter is repeated, and AA, where the same letter is repeated twice. So now we can apply the permutation formula with replacement here. So the number of tickets that are composed of 2 letters is the permutation of 2 ordered letters taken 2 at a time with replacement. And now we use this formula, permutation with replacement of 26 letters taken 2 at a time, which is 26 to the power of 2, which is 676 tickets. So we can issue in such case 676 tickets only. Or we can use the table to know the number of possible tickets. So here we have the first withdrawal, and for the first withdrawal we have a 26 letter we can withdraw from, and for the second withdrawal again we have 26 letter we can withdraw from, and the number of all possible tickets is 26 times 26, which is 676 again. The second question is that how many tickets can be issued that have 2 different letters. So we may have a ticket holding AB or BA or AC, but we cannot have a ticket holding the alphabet AA, BB, CC, etc. So what does that mean? It means that repetition of the letter is not allowed. So here we have permutation without replacement. So now we have these 2 conditions. letters are ordered in the ticket and replacement is not allowed. So in such case, we use the formula of permutation without replacement of a 26 card taken 2 at a time, and this is 26 times 25 equal to 650. Or we can use the table and we write these events or these withdrawal in order. So for the first withdrawal we have 26 letters can be chosen. For the second withdrawal we have only 25 letters. So the number of tickets that can be issued with 2 different letters, 26 times 25 equal to 650 tickets. And this is the number of tickets that has 2 different letters. So the question is, how many tickets can be issued that have 2 identical letters? If we remember from task 9 that the difference between permutation with replacement and permutation without replacement is going to give us the number of sequences that has at least 2 identical letters. So now we can use this difference here, permutation with replacement minus permutation without replacement of 26 letter taken 2 at a time, and we are going to get the 26 ticket or 26 sequence that has at least 2 identical letters. And here we have only 2 letters, so we are going to end up with 2 identical letters only. And we are going to get sequences or ticket holding these alphabet AA, BB, CC, DD until ZZ. So this is 26 letter in English with 26 repeated ticket letter. Now if the ticket is composed of 3 letters only, then each generated sequence should have 3 letters. So in such case, R is equal to 3, which is the number of letters in the generated sequence. Now, how many tickets can be issued if the player can choose 1 letter from each of the 3 lines in order? So let's have a look at the ticket. So we have here first line, and we have here second line and third line. And the player may choose, let's say, W, and we'll write it outside in order. And from the second line he may choose B, so this is the second letter. And from the third line he may choose Y, and we write it here as the third letter. And now we have 1 ticket with 3 ordered letters W, B, Y. So the question is, can the player repeat the same letter in the ticket? And the answer is yes, he can choose from the first line Q, and the second line Q, and the third line Q, and we may get a ticket such as QQQ or QQA, whatever. So we can repeat the letter, which means replacement is allowed. So now we have these 2 conditions: ordered letter in the ticket and replacement of the letter is allowed. So we may get sequences such as ABC and AAA and ABB, where letters are repeated sometimes here and not repeated here. So we have 2 kinds of sequences, with repeated letter and without repeated letter, and we apply the permutation with replacement formula of a 26 letter taken 3 at a time, which is 26 to the power of 3. And now the Lottery Corporation can issue 17,570 tickets composed of 3 letters only. Or we can use this table here. We can write the withdrawal event in order, and for the first event we can withdraw 26 letters. For the second one we can withdraw 26 also, because it's with replacement. And for the third one we can also withdraw 26 letters. So the total number is the multiplication of them, and which is also 17,570. 576 tickets that can be issued. Now the question is, how many tickets can be issued that have 3 different letters? In such case, we may have letters such as ABC, CBA, but not AAB or CCB, so the letter cannot be repeated. So this is a case of permutation without replacement. So here we have 2 conditions: ordered letters and replacement is not allowed, and we use the permutation formula of 26 letters taken 3 at a time without replacement. So we have 15,600 tickets that has 3 letters different from each other. Or we can use the table. We write the event or the withdrawal in order, and for each one, for the first withdrawal we can withdraw 26 letters, for the second we can withdraw 25, and for the third we can withdraw 24, and we multiply them together and we get the number of tickets. Now the question is, how many tickets can be issued that have at least 2 identical or repetitive letters? So the ticket may have 2 repetitive letters or 3 repetitive letters, because the sequence length now is 3 symbols, not 2. So as we have seen in task number 9, that the difference between permutation with replacement and without replacement is going to give us all sequences that has at least 2 identical letters. So we may have sequence AAB or AAA or YYY, etc. And now we have 1,976 tickets that has at least 2 identical letters. Now in case the ticket is composed of 4 letters only, so R is equal to 4, we follow the same previous reasoning exactly, and we get the number of tickets that can be issued by the corporation if the ticket has 4 letters will be 456,976 letters. And we follow exactly the same reasoning. The only thing is when we compute permutation of 26 letters taken 4 at a time, now it's better to use this formula, 26 factorial divided by 26 minus 4 factorial, because multiplication has grown bigger than before, and now we get the tickets that can be issued that have 4 different letters, 358,800, and the number of sequences or tickets that has at least 2 identical or repetitive letters is going to be 98,176. Thank you for watching and have a good day.